In this question, A, B and C are the sets such that A union B is equal to A union C and A intersection B is equal to A intersection C, and we need to show that B is equal to C. So the general way that we have been following to show two sets to be equal, what we show is that B is a subset of C and C is subset of B. Only then, if and only if it is true, then B is equal to C. So my target will be to show that set B is subset of C and set C is subset of set B. Okay, and I will use these conditions to do that. So let me start with the X belonging to B. If let us say X belongs to B, this is how we show these subsets, that I start with X belonging to B, and if this will imply that X also belongs to C, then I'll say B is subset of C, right? So let me start with X belongs to B. So if X belongs to B, that means X certainly belongs to A union B, right? If there is an element that belongs to B, it will definitely belong to A union B, right? And A union B is equal to A union C. So this implies that X will belong to A union C, right? And if there is an element that belongs to union of two sets, that means that X belongs to A or X belongs to C, right? There is sense of or here. It belongs to A or it belongs to C, or it may belong to both. But this is always true, that it will belong to A or it will belong to C. This is what union is, right? Now there are two conditions. One, second, right? And you remember we started with X belongs to B. So if this is true, right, this would imply, now we started with X belongs to B, and if this is true, then X belongs to C, so it will mean B is a subset of C, right? The second scenario is when X belongs to A is there, right? So X belongs to A, what does it mean? That it will definitely belong to X will definitely belong to intersection of A and B, right? If it belongs to A, if it belongs to A, and we already know that it belongs to B, right? Because this is what we started with, and here I know that it belongs to A. So if it belongs to A, then it definitely belongs to A intersection B, because we started with B here, right? So what I mean to say is X belongs to B and X belongs to A, so it belongs to their intersection also. So if it belongs to A intersection B, then it also belongs to A intersection C, right? Because this A intersection B is equal to A intersection C. And now if it belongs to A intersection C, then I can say that it belongs to C, right? So what do you interpret when I say that an element belongs to intersection of two sets? That means this element is common to both these sets, so it belongs to A as well as C. So I can say X belongs to C. Now I started with X belonging to B and I reached at X belongs to C, so I can say that set B is subset of set C, right? So this is, my job is half done, because I have proved till now that in all these circumstances, right, I started with X belonging to B, so I said that X also belongs to union of A and B, and X belongs to union of A and C, because A union B is equal to A union C. And if it belongs to A union C, then it belongs to A or it belongs to C. If it belongs to C, then I can directly say that B is a subset of C. If it belongs to A, then it will belong to A intersection B, because we already know that it belongs to B, right? It belongs to B as well as A, then it belongs to A intersection B, which means it belongs to A intersection C. Hence it belongs to C. That means B is a subset of C. Now I need to show that C is subset of B. So let me start with an element Y belonging to C. And if in the end I am able to show that it also belongs to B, then I'll say set C is subset of B. So if it belongs to C, that means it will belong to, Y will belong to union of A and C, right? If an element is there which belongs to C, it will definitely belongs to C union some other set, right? Because all the elements of C will be there, right? So A union C is there. Now this element Y belongs to A union C. So that means Y belongs to A, or Y belongs to, now Y belongs to A union C. A union C in turn is equal to A union B. So let me write one more step, then we will do that, right? Now A union C is equal to A union B. So let me write A union B here. Now I'll do the same exercise that I did here. So what I'll do is I'll make two cases. Now this is union, right? It gives me or. So Y belongs to A or Y belongs to B. And if Y belongs to B, then that means I started with Y belonging to C and I reached at Y belongs to B. So I can say C is subset of B. Now there is another scenario when Y belongs to A. If Y belongs to A, then Y belongs to A intersection C, because I already know that it belongs to C. So I can say it belongs to A intersection C, right? If Y belongs to A and I already know that it belongs to C, that means it belongs to intersection of A and C. It is clear? So now what can I say? A intersection C is equal to A intersection B. So what can I say about Y? Y belongs to A intersection B. And if it belongs to A intersection B, then it surely belongs to B, right? Because if an element belongs to intersection of two sets, then it means it is common in both the sets, or it belongs to both of these. So Y belongs to B. So Y belongs to C implies that Y belongs to B, means C is subset of B. So I started with this and I reached at conclusion in both of these scenarios that C is subset of B. Hence I can say that set B is subset of C and set C is subset of B, which implies that set B is equal to set C, right? This is what we need to prove in this question. Now we need to show that these conditions are equivalent. If I say that A is subset of B, it is equivalent to saying that A minus B is phi. It means, let us say there is set B and there is another set A which is subset of B, right? Now I need to check this second statement. A minus B is phi. What does it mean? What is difference of sets A minus B? That every element that is there in A but not in B, right? So if I talk about a general element X, then I'll say X belongs to A and not B. So if the first statement is true that A is subset of B, can there be any element in A which is not in B? No. So it is phi. Hence it is equivalent to saying that A is subset of B. This second statement means what? If I say this statement in English language, it means there is no element in A that is not there in B, right? A minus B means elements of A that are not there in B. So if it is phi, so it means that there is no element in A that is not there in B. So it means A has to be the subset of B. So it is equivalent statement of this statement, right? Now the third statement, if you see, A union B is B. So if A is subset of B and I take their union, the union will be the bigger set. So if I take this set and this set, the union will be this set obviously, and intersection will be the inner set, right? This will be the common area to both of these sets, and what will be their union? Union will be this, right? So all these statements are equivalent. Now how to show them mathematically that they are equivalent? Let us check. So let us first of all see A is given as subset of B, right? Which means, this means that every element of set A is there in set B, right? Or mathematically, if I say that if X belongs to A, it belongs to B, right? Now the second statement, this is first statement. Now the second statement says A minus B is equal to phi, right? That means X, if X belongs to A and X doesn't belong to B, this is A minus B, right? There is no such X. So X belongs to A and X doesn't belong to B. There is no such X, right? So A minus B is given phi, right? So what does it mean, phi? The empty set. So there is nothing that belongs to A and doesn't belong to B. There is nothing that belongs to A and doesn't belong to B, right? That means A is subset of B. Or if you want to write one more statement, when I say that there is nothing that belongs to A and doesn't belong to B, you can make a statement that every element of A is there in B, right? So A is subset of B. I hope first two statements are clear to you, and this is enough to write whatever I have written. If you can write this much, this is enough to show that these two statements are equivalent. Now the third statement says A union B is equal to B, right? So let us see, if let us say X belongs to A, that will mean that X will belong to union of A and B, right? And union of A and B is given equal to B, so that means X will belong to B. Now we said that X belongs to A, and as per the given statement X also belongs to B. What does that mean? That means A is subset of B. So this statement is also equivalent of the first statement. Okay, let us look at the last statement. A intersection B is equal to A. Last statement is this one, right? Now we need to see whether this is equivalent to the first statement or not, which was A is subset of B. Let me show you. This was the first statement, and we need to see whether this is equivalent, this fourth statement is equivalent to it or not. So if I consider that X belongs to A, right? A is subset of B. So if X belongs to A, then can I say that X will belong to A intersection B? In general, it is not true, right? If you see that there is this set A and there is this set B, let us say. If there is something in A, it may or may not be in B. If there is something else in A, it may be there in B, right? So it may or may not be. But now in this statement, fourth statement, it is given that A and A intersection B are equal, right? This is equal to A intersection B, A. So what I can do is I can simply replace this A with this. So if this is true, we have started with X belong, now this is what we have considered, right? X belongs to A. So we can say that X belongs to A intersection B because it is given equal to A intersection B, right? Not because it is always true, because it is given in this question. So if it belongs to A intersection B, then we can say with certainty that it will belong to B also, right? If it belongs here, then it belongs to both the sets, right? It is common to both the sets. So if X belongs to A means that X belongs to B, I can say that A is subset of B. So I have related all these four statements, right? These are equivalent statements, and we already know this from the basic understanding of sets, that We already know it, right? Because if there is, let us say, a big set and a small set, which is subset of it, we know that if I take their intersection, the smaller part will be common to both. So the answer will be the subset, because A is subset of B, then their intersection will give me A back. And what will be their union? It will contain all the elements of A, all the elements of B. So this will be the bigger set, that is B, right? So if I take the intersection of these two sets, then it will give me the subset as my answer. If I take union of these two sets, it will give me the superset as my answer, right? This is something that we have already studied while studying the basics of this chapter, sets. Okay.